the circumcenter. So now we're going to start looking at centers of triangles. Well, what does a center of a triangle mean? Well, there's different types of centers. Your first one we're going to look at is the circumcenter. This is the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. So your circumcenter is made up of your perpendicular bisectors, where they intersect at. The circumcenter is always equidistant from the vertices, so that's important to note. It's equidistant from your vertices, your angles. Use your diagram to the left to answer your following questions. So list your perpendicular bisectors. Well, if we look, our perpendicular bisectors are PF, PD, and PE. So let's go ahead and we'll highlight these so we're aware. These are our perpendicular bisectors. So if you look, PF, PD, PE. If we name the center, that is point P. And then it says list all congruent line segments. So we have AD is congruent to DB. So if you look, that's on your triangle. AD is congruent to DB. BE is congruent to EC. AF is congruent to FC. So each of our legs, remember your perpendicular bisector bisects at the midpoint. So that's what's making these parts congruent. Then the last part that's kind of new that we need to recognize is that AP is congruent to BP, which is congruent to CP. So that is the extra part. If you look, so this part, AP, is congruent to BP, which is congruent to CP. That's the part we just listed out. Those are all congruent. So I'm going to go ahead and put 4 hash marks on the green parts because they are all congruent to each other. And that's the rule you need to recognize, all right? And also note that each of these perpendicular bisectors, when made with the leftover part of the perpendicular, or what it cuts the triangle into, is making a right triangle. That's important for when we're solving for missing parts. So let's look at number 1. I'm going to do 1 and 2. So number 1, if Z is your circumcenter of triangle TUV, find each missing measure. So let's look. A is asking for TU. So TU, remember, this part is congruent to this part, so they're both 19. 19 plus 19 is 38. So we'll do, I'll write it down. VY is right here. Well, now they gave us 34 is the whole part, so half of that is 17 and 17, so VY is 17. UZ, if we look, UZ, let's find it. UZ, if we identify our perpendicular bisectors, right there, just like our notes, we can make these guys green. So we see that UZ is one of the green parts. It would be congruent to the other green one. So this VZ is 21, so that means that UZ is going to be 21. That's just based off of the rules that we've identified. Our last one, or not our last one, but D says what is WV? So looking at my picture, WV is this line right here. So I said keep in mind, these little triangles, we would need that information because we're going to have to use the Pythagorean theorem. So if I draw my little triangle that it makes, well, here's my right angle, I know that the hypotenuse is 21. Remember, your hypotenuse is across from the right angle, and the one leg is 15. My WZ is the x. That's what we're trying to solve for. So we'll use our Pythagorean theorem to solve for letter D. So it's a squared plus b squared equals c squared. Remember, across from your hypotenuse, is the letter C. So we'll do x squared plus 15 squared is equal to 21 squared, and then we'll solve it out. So x squared plus 225 is equal to 441. If we subtract 225 from both sides, we get x squared is equal to 216. If we take the square root and we'll round to 1 decimal place, we get that x is equal to 14.7. So that's the length of that side. So my x is 14.7. We need to know that then because the last one asked what's the length of TV. Well, if we double it, because if this one's 14.7, then that one is 14.7. So 14.7 plus 14.7 is equal to 29.4. Right triangles. Pythagorean theorem is your friend. So let's do one more, number 2, with circumcenter. So if H is your circumcenter of triangle triangle BCD, find each measure. So just like I did before, so I don't get confused, I'm going to identify my perpendicular bisectors, then my other congruent segments, from the triangle. So it wants to know, let's look at the first one. If I draw my right angles, there's my triangles that are made. It wants to know what's the length of GD. Well, the whole part down here is 24, so half would be 12. So GD is 12. What's the length of BC? Looking at, here's BC. Well, if this part's 7, then this part's 7. So for BC, 7 plus 7 is equal to 14. Then we look at letter C. It wants to know what's the length of EH. EH. Well, if we look, we have a right triangle. So let's draw it. There's my right triangle. We're solving for letter C. If we label my triangle sides, across from my right angle is the hypotenuse, it's 13. The bottom leg is going to be 7. So if we use our Pythagorean theorem, a squared plus b squared equals c squared, and we substitute in, my unknown is a leg. So we'll have x squared plus 7 squared is equal to 13 squared. So x squared plus 49 is equal to 169. Subtract 49, we get x squared is equal to 120. If we take the square root, x is equal to 11. So looking now, it wanted to know the length of EH. EH is going to be 11. Let's look at letter D. It wants to know what is the length of FD. Looking at our picture, FD is the length right here. FD is that length. So if we look at our triangle, we draw a triangle. If we look at that picture, we can see that one of the legs is 3. Oh, there it is. Sorry, I was looking for my missing piece. All the green parts are the same. They're all equal to 13, so that means that my hypotenuse is 13. We all get a little lost. You got to go back to your rules. It tells you what's what. Remember, that's why the highlighting helps us. The greens are all congruent thanks to the list of all congruent segments in our notes. So if we write out a squared plus b squared equals c squared, and we substitute in, we have x squared plus 3 squared is equal to 13 squared. So we have x squared plus 9 is equal to 169. We subtract the 9, we get x squared is equal to 160. We take the square root. We get that x is equal to 12.6 when we round to 1 decimal place. So that means that this guy is 12.6, so this guy is 12.6. He wants to know the length of CD, which is the whole length over there, and luckily we just found half, so 12.6 times 2, so 2 times 12.6 gets us that our answer is 25.2. A little lengthy for Circumcenter. That's okay, just practicing our right triangle. So let's turn to the back and we're going to do the in-center. What is the in-center? Well, looking at the definitions and the information, your in-center is the angle bisectors of the angles of a triangle intersect at a point called your in-center. So when your angle bisectors intersect, that's called your in-center. The in-center is always equidistant from the sides of your triangle. So that's important. When we like the word equidistant, that means that they're the same. Use your diagram to the left to answer your following questions. So in words, this is what it means. Now, what does it mean when we look at a picture? So list all the angle bisectors. So looking, it's going to be PB, PC, and PA. Let's write that down. My angle bisectors are PB, PC, and PA. So we highlight with a purpose. Our yellow ones are the angle bisectors. Name your in-center. Well, the in-center is still on this one, point P. List all your congruent segments. PB is congruent to PE, which is also congruent to PF. So once again, let's highlight with a purpose. For pink, with our in-center, PB, PE, and PF. I think I wrote the wrong one. I think that's supposed to be PD, right? PD, PE, and PF. Sorry. This right here should be PD. All the pink ones. And then if we look on here, what also happens now is that AD is congruent to AF. AD is congruent to AF. We have BD is congruent to BE. So BD is congruent to BE. And last but not least, but CE is congruent to CF. All right? It's a lot. List all your congruent segments. That's what we did. So, if P is your in-center of triangle JKL, find each missing measure. So if P is your in-center of triangle JKL, find each missing measure. So let's start with highlighting. Let's highlight, oh, I guess it would help if you could do the question, huh? Number 1. Let's highlight all of our angle bisectors. So that would be the ones, remember, angle bisectors, bisecting your angles. So it's the ones that are coming out of your angles. And then, right there, your missing segment. Remember that the ones in pink are all congruent to each other. Okay, so let's look. Letter A, NP. Looking at my picture, we're trying to find NP, which is this guy right here. Well, remember the pink ones are all the same. If this pink one's 8, then that means that pink one is 8. So NP is going to be 8. Then it asks what's the measure of NK. Well, remember, based on our picture above, if this one is 17, then over here the opposite side is also 17. So NK is 17. Next is PK. Looking at my picture, PK is right here. Well, remember, these pink ones are your perpendicular bisectors, so they make right angles. So those right triangles did not go away. So solving for letter C, if I was to draw my triangle, here's my right angle. This is 17. This is 8, and I'm solving for my unknown, which that is my hypotenuse. So using a squared plus b squared is equal to c squared, we're going to substitute in 8 squared plus 17 squared is equal to x squared. 8 squared is 64. 17 squared is 289, which is equal to x squared. 353 is equal to x squared. Take your square root, round to 1 decimal place, you get 18.8. So PK, which is this guy, is equal to 18.8. Last but not least is letter D. D is equal to LO. That's this line right here. Well, if we do our right triangle again, the pinks are all the same. The pinks are all equal to 8. Our hypotenuse, because this is my right triangle, is going to be 13, and we're solving for that unknown lead. So if we write in a squared plus b squared equals c squared, your hypotenuse is the 13, so we get x squared plus 8 squared is equal to 13 squared. So x squared plus 64 is equal to 169. Subtract 64 from both sides, you get 105. Take your square root, you get that x equals 10.2. If you have any questions, it's all about your right triangles. Always refer back to your notes, okay? That's going to help you if you have missing information.